Hello again. I'm doing a video to show another way to do the problem I did on the last video. I think this could help you in both problems 11 and 12. If you remember what we had that diagram of a room, of a factory, let's call it, a place where the robot works. The robot's clearly now, right at this moment, in room D. We have boxes in 1, 2, and 3. Boxes 1, 2, and 3 in 3 different rooms. This tells us the current state. That's what we know. Call that our knowledge base, KB. What do we want? Well, we want to get all 3 boxes in one room. That is what we are trying to do. In resolution theory, the idea is to put the negative of what we want into our knowledge base and prove that that causes a contradiction. And since we don't believe that we can reach a contradiction by starting with true statements, then the statement that isn't true is the negative, because all the others we believe are true. Now, the way we do this is to use what is called a clash. Each of the items in our database is a clause. And these are simple clauses. You'll see a more complicated one in a minute. If what we do is we look for 2 clauses, one has to have a positive and the other a negative of the same predicate with its filled in X's and B's and whatever. The case I use most of the time is P and not P or anything else. But you could have not P and P or anything else. Or you could even have P and not P and have anything else's in both cases, in which case you'd OR them together when you're finished. So what this basically says is, we can eliminate something. Our goal is to eliminate till we get down to nothing. And when we get down to nothing, that's our contradiction. Now, these are the operators in strips that I gave you so far. There's a different set of operators for homework 12. I made up 2 new ones. But look at these are what we can do. We want to plot out a plan for the robot. How is he going to do this work? And the steps he can take are pushing something from one room to another and going from one room to another. That's all he can do. In each of these steps, we have what needs to be true in order to take the step. And then if we take the step, what we can change and what we can add. So to be able to take this step, we have to prove that this is true, that at KM and ATRM is true for some M and some K. So far we have this much knowledge in our database. And here's the more complicated clause I told you we had. These are called conjunctions. We have either a positive or a negative item, or a positive or a negative item, or a positive or a negative item. If we had an and when we were translating things, that turned out to be 2 clauses. So now, we're really going to do, I said 3, but I think it's actually 4 problems of the resolution proof type. We want to prove that we can do pushes box 3 DC. Well, we can only do that if we can get this precondition. So we take the negative of the precondition, which I've added, and now we try to find clashing. Well, I made a substitute. I put box 3 in for the K up here, and I put D in for the M, and I did this, and then I had this as one of my statements. So I have a positive and a negative. I can remove this negative. I can remove this negative because it's got a positive here. And I have ATRD. And I also have this. They can't both be true. There's my contradiction. Now, the reason I can remove the ATRD, the first item here, is because I know both statements are true. If this is true, then that's got to be false. None of it is false. And this is an or. Something has to be true. So the rest of it has to be true. So now we are entitled to make the changes. So I made the changes in my database. The robot's in a different place, and box 3 is in a different place. Everything else remains the same. Well, I'd like to move box B1 into B. But to do that, I have to get the robot into B. So I have to move the robot from C to D. In order to do that, I have to have the condition, the negative of my condition, precondition, which is at robot C. So if I can show you that the robot is at C, I can do it. And that's easy. I have that in the database already. Contradiction. Now I can add a change to where the robot is and a change to where that's it. So the robot's now in B. Box 1's in B. I do the same thing I did before, do almost the same clashes, and add in the new items. And this is the final problem we have to do. We have the contradiction in there. We have the negative of the conclusion. Can we reach a contradiction from here? Well, that turns out to be pretty easy. We just keep clashing them one by one until we come up with that there's nothing left. And that proves that there is some X, in fact, X is C, so that all the boxes are in the same room. Now, there are 4 resolution proofs. In problem 11, what you're doing is one resolution proof. You're taking the statements that are there and trying to reach a conclusion, a contradiction. In problem 12, you're trying to outline a set of actions, and you can pretty well tell what they're going to be. But you have to justify each action by doing a resolution proof to show you have the precondition, and then you can make the changes. I hope that helps you for solving the problems. They're very mechanical. It's completely automatic. You're just, in fact, you could almost say that once you get it translated, the machine doesn't care what it means. It just does it. So I hope that helps.